this is the last topic under Unit 1. So, hope today I will finish this. Under correlation, what we need to study? We can able to check whether the two variables will be having some relationship or not. That means the term correlation or covariation indicates the relationship between two variables in which one variable will change, the other variable will also be changed. Or if one variable will change, the other variable won't be changed. So such kind of relationship we may analyze by knowing this correlation concept between the two variables. This correlation analysis is also helpful us to ascertain the strength of relationship between the two variables. So we can analyze that how much the strength will be between the two variables. So this correlation is having different types. First one is positive or negative correlation. Positive or negative correlation. And second one is simple, partial or multiple correlation. And the third one is linear or non-linear correlation. Linear or non-linear correlation. So we are going to analyze the relationship. Either it may be a positive or negative or whatever it may be the relationship between the two variables, we can analyze or we can find out by using these kinds of different types of correlations. Okay, positive or negative, simple, partial or multiple correlation, linear or non-linear correlation. Okay, first we will discuss about positive or negative correlation. This positive or negative correlation depend upon the direction in which the variable is moving. Just write down, just put it heading like positive or negative correlation. Positive or negative correlation. This will be depends upon the direction. This will be depends upon the direction in which the variables are moving. In which the variables are moving. It will comes under either positive or negative correlation. Okay, see how the variables are moving in one direction or in the opposite direction. We have two variables, right? We just assume it as x and y. We have two variables. Okay, so these two variables may be traveled or moving either in same directions or in opposite directions like this. So how you can able to represent these two directions by showing it on the graphs. By showing it on the graphs. See, roughly I am telling, okay, it is just for the example. It is an x variable and it is an y. So if x and y, these two variables are moving in this direction only, you may call it as positive. Okay, if one variable is traveling in this way and other variable is traveling in this way, you may call it as negative. So how these variables may travel in these directions based upon their values. Based upon their values. So we have a data of x variable and y variable like 10, 20, 40, 50, 60, whatever it is the data. So when you take these values for plotting these on the graphs, so you can able to find out the variables will follows positive direction or negative direction. Okay, you just observe it. Just observe it by recording this data. Just write down positive correlation, positive correlation and negative correlation. You just observe this data, you can able to know how the positive will be and how the negative will be. So in case of positive correlation, how will be the result? Both x and y variable, both x and y variables are increases, or both x and y variables may decreases. See, you just note down under x and y. You just write it down, these two under positive correlation. How I am writing? In the same pattern, you just write it on your notes. So the x variable first value will be 55, then it will be 62, then it will be 67, then 72, then 77. How the values will be? These values are increasing from the first value to the last value. That means the x variable values are increasing. And how about y? See, 21, 27, 30, 35, and 42. So what about this y variable? This variable is also having some increased values from first value to the last value. So what you can able to find by observing these two variable values? With both x and y variable values are increasing. You just write down under x and y variables are increasing. Put it a column like x and y, just write down these numbers. Then you can able to understand what is going to happen. And in case of both x and y variables will be decreased, just make it down. Then 35, 30, 25, 21, 15. Just observe the values. Then 47, 44, 42, 37, 33. Are you getting what I am telling you? So either the values may be increased or the values may be decreased. These will comes under positive correlation. If suppose it will be a negative correlation, just write down one variable increases, one variable increases, other will decreases, other will decreases. Just write down x and y, 40, 45, 52, 60 and 65. And here 30, 25, 21, 15, 12. So in this case, the x variable values are increasing, but the y variable values are decreasing. So these are following opposite direction, right? These are increasing in this pattern and y variable values are decreasing in this pattern. So this is going down and this is going up. So here the opposite direction is observed. And then this is one case. If one variable increases, other will decreases. Okay. So you just write down vice versa. That is, one variable decreases, one variable decreases, other variable, other V stands for variable, will increase, will increase. Just write down like that. Just make it down two columns, 60, 55, 51, 45 and 40. And here 45, 50, 52, 57 and 62. So how the values will be here? The x variable values are decreasing, but the y variable values are increasing. That's why one variable is decreased with other variable is increasing. So this is what the positive and negative correlation, and how the movement of variables, as we observed here very clearly by seeing these values. Okay, just note it down. Are you getting? Is it clear?
Yes, yes, ma'am.
Okay. Then coming to the next one, simple, partial and multiple. What do you mean by that exactly? Simple means, anyone? Here we are going to study about only two variables. Here we are going to study about two variables. That is, the number of variables will be 2. The number of variables will be 2 in case of simple correlation. Simple correlation. In case of partial and multiple correlation, the relationship between two or more variables, the relationship between two or more variables we studied. In case of simple correlation, we are going to study about only two variables. In case of partial and multiple correlations, we can able to study the relationship between two or more variables. In case of multiple, there will be n number of variable studies. N number, either it may be 3, 4, 5, 10. N number of variable studies will be included in multiple correlation. Okay, this is what the difference between positive, negative, simple, partial, and multiple. And one more important type of correlation you have, that is, this is the third one and this is the second one. Linear and non-linear. I think you already studied under BPPK. Under BPPK subject, you already studied about zero order and first order. I think so. Is it right? Zero order and first order. So how the graphs pattern will be? Either the graph will be like this or the graph will be like this. Okay. If the graph is showing you as a straight line like this, it will be said to what? Linear. The relationship between the concentration or the time values of plasma will be a linear relationship that we can say by seeing that particular graph between the plasma drug concentration versus time profiles of a particular drug. That will be in the case of pharmacokinetic studies, right? So you just apply what you know about the linear and non-linear in the statistics. Linear and non-linear correlation. The distinction between, just write down the distinction between linear and non-linear correlation. The distinction between linear and non-linear correlation is based upon the ratio of change between the variables under study. Okay, just write down next point. If the variation in the two variables, have a constant ratio, then it is said to be a linear correlation. See, once again, you just check it down. The distinction between linear and non-linear correlation is based upon the ratio of change between the variables under the study. If the variation in the values of two variables will be a constant ratio, then we may call it as linear correlation. Okay. So you just find out the variable, x and the variable y values, how these will follows linear correlation. I will explain you. Just write down these values. Okay, 10, 20, 30, 40, 50, and 60. Okay, so I am explaining you about linear correlation, right? Linear correlation. See, if you consider this x variable values, what is the difference between these two values? Huh?
30, ma'am.
30. It was exactly maintaining a constant ratio, that is the 30. And in case of variable y, it is maintaining
10.
10.
constant ratio of 10. So here what we observed, what is the definition of linear correlation? The variables will be traveling or moving with respect to the constant ratio of the particular values. Then we may call it as linear correlation. If they won't be traveled in these particular constant ratios, we may call it as non-linear. Suppose if the arrangement of the values will be in a zigzag manner, that means here it will be a 30, 60, and then it will be a 70, 80, then again 90, then again 120, like that. The constant relationship between these values may not be maintained in case of non-linear correlation. That is the main difference. Okay. Yes, till now we have learned about different types of correlations. Okay, then the next step is methods of studying correlation. Methods of studying correlation. Methods of studying correlation. How many methods you have to study about correlation? See, we may explain all these types of different types of correlation by using two different methods. First one is graphic method and the second one is mathematical method. So we can able to tell by plotting our graphs by the use of graphic method, or we may derive our data with the help of mathematical expressions or mathematical equations. We may tell it as either it is following simple correlation or negative or positive or whatever it is, the type of correlation, right? So majorly we have two different types of methods to explain about correlation. Under graphic method, you have two types. First one is scatter, SCATTER, scatter diagram method. Scatter diagram method. And the second one is graphic method, it's same. Graphic method only. Okay. Under mathematical method, you have car, Pearson, PEARSON apostrophe S. Correlation, coefficient. Correlation, coefficient. And the second one is Spearman's rank, correlation, coefficient. We have these four types of methods are there to express our variables correlation. Okay, in your syllabus, they mentioned about clearly Carl Pearson correlation coefficient. So you just learn this one. It is enough for you. But you just know about these methods also in few points. Okay. So first one is scatter diagram method. Scattering means what? Generally, I am asking you. Scattering means what? You just plotting whatever the data you have, you just plot those values on a graph paper. See, for example, I'm telling, we have, okay, this is 15, 30, 45, 60. So if you take the value, if you take the variable on x, on y, so x values, you can take it as, you just divide it as in units 10, 20, 30, 40. Okay. Under y, this is 10, this is 15, 20, 25, 30, 35, like that you can take. Means you just scattering your variables on this graph. How you are scattering? This is 10 and this is 15. So this is 10 and this is 15. You just indicated that scattering with the dot. Then next one is 20, 30. 20 here and 30 is here. 30, 45. 30 and 45. Suppose it will be here. So like that. So here what you are going to do? You are scattering your variables on a graph. So this is what the scattering method. So you just know how the variables presentation will be. That is enough for you. But in your syllabus, they mentioned only about the Carl Pearson method. That is the most important thing. Okay. So the simplest method, you just write down one point under scatter diagram method. This is the simplest method for ascertaining whether there is any relationship, present. This is the simplest method for ascertaining whether there is any relationship, present between two variables, by plotting the value on a chart, is known as scatter diagram, So this is also having different types, positive or negative. So if your graph is going like this, that means your plotted variable values will be like this. It is saying a positive scattering. If your values will be like this, that is indicated you the negative scattering. So positive and negative is also there. Okay, similar like your positive and negative correlation. So here it is following positive scatter correlation and it is negative scattering correlation. If the graph is like this, if the particles are showing, if the variable values are showing like this, is there any scattering is present in this graph? We may call it as what? Zero scattering or no correlation. If the graph is like this, that means the arrangement of the movement of the variables will not follow any orderless arrangement. These are randomly arranged. So in such case, we may call it as zero scattering or no correlation between the x and y variables. Okay, so this is about the scatter diagram method. And the next one is graphic method. Are you able to understand what I am telling you? Next one is graphic method. This is the another method, write down. This is the another method for ascertaining the presence of correlation between two variables. This is another simplest method for ascertaining the presence of correlation between two variables. The individual values of variables, x and y, are plotted on a graph paper. If it is possible, after completing this class, once I will explain you the scatter and graphic method on the Excel. Okay, I will show you how to find out the difference between scattering and graphic method. I will explain you. Okay, the individual values of two variables x and y are plotted on a graph paper. On a graph paper. See, this is the x and this is the y, no? So we have some values. We have some values. So if you plot these values, after scattering these values, you may join those points. Okay, if your values will be like that, you just join these values. So this may call it as graphic method. So what you are going to do here, after plotting the points, we are joining the line. So we are plotting that variables on a graph paper. So that is what the graphic method. These are two graphical methods to express our correlation. Okay. So the next most important one is the mathematical expression of correlation. Mathematical methods. So you just focus only on Carl Pearson method. Pearson's method. Okay. Carl Pearson's, write down one point. Carl Pearson's measure of correlation is based on arithmetic mean and standard deviation. This is the first foremost important point. Carl Pearson's method. Carl Pearson's method is a measure of correlation is based on arithmetic mean and standard deviation Okay, this is the first point. And in the next point is a mathematical measure of next point, a mathematical measure of a mathematical measure of calculating magnitude of linear relationship between two variables. So Carl Pearson method is a mathematical measure which will be calculating a linear relationship between the two variables. Okay. And the next one is based on the arithmetic mean and SD. The equation will be there. So all of you should write down the equation. Small r is equals. Write it neatly. This is a very important question. Equation is also very simple to remember. Observe it. First, you remember that Carl Pearson correlation is analyzing or measuring the relationship between two variables x and y. And it will be based on arithmetic mean and SD. So in the SD, we have the formula. What is the formula for SD?
Under root.
Okay, so this is the under root. So x minus x bar is there. And here x minus x bar is nothing but arithmetic mean. So you just remember like that. Just remember on the basis of concept. Then it is very easy to write the equation. Okay. Then just write down first this equation where x is independent variable. Write down x is independent variable, independent variable, y is dependent variable, x is independent variable, y is dependent variable. So you already know that x bar is with respect to the independent variable x arithmetic mean, y bar is dependent variable y arithmetic mean. Okay, and one more important thing, x minus x bar means what? I think you already know that. X minus
dx
x
bar,
bar is nothing but
dx bar.
yes, small d, right? We are finding out some deviations from this. What is that? Individual observations minus arithmetic mean. So we can write the equation sigma dx into what? Dy divided by sigma dx square. Sigma dy square. See how the equation will be. Okay. First, you just remember this equation. We already know that x minus x bar is dx. So then you just substitute these values. Dx into dy, dx square into dy square. The simplification, you just write down up to this formula. Yes, all of you write down it. Then next step, the simplification of the components of the formula, the simplification of the components of the formula of the components of the formula is dx into dy is equals xy minus x into y divided by n. First you write down this, then you just write down these all, then second equation, then the simplification of the components of the formula. What are the components? Dx and dy is equal to x and y, x into y divided by n. N is number of observations. Then dx square, this is x square minus x whole square divided by n for finding out x variable. For finding out y variable, it will be y square minus whole square divided by n. Okay. You just write down one point here where dx dy can be either positive or negative. Dx dy can be either positive or negative depending upon whether the correlation is positive or negative. Whether the correlation is positive or negative. And you just write down one subheading. You just write down like a subheading. Interpreting the coefficient